Some days conditions make it hard to hear or make contacts using conventional speech or Morse, and that's when data modes can really help you keep your hobby alive. But not everyone is into computers enough to know what software to use and how to link them up to their radios to make those data mode contacts a reality. Our next guest is something of a radio computer guru and will take us through the basics, so it's a warm convention welcome to Mike Richards, G4WNC. Mike.
Hello, David, and hello, everyone. Thank you for joining me this afternoon. A big thank you to all the team at the RSGB, both yourself and Tammy and all the workers in the background that are making this happen. It's great that we can still continue with the convention.
It's a lovely, and if I could just mention there actually, Mike, as well as that, you can ask questions of Mike at any time during his talk or straight afterwards, but you need to be quick. So if you think of something you'd like to ask Mark, just ask it on the YouTube chat and we'll be happy to feed that back to Mike so that he can answer it. Right, Mike, back to you.
Yeah, that's fine. Okay, so this is what I'm going to attempt to cover this afternoon. So we're going to talk about what are data modes, how do they work, what do you need in order to get operating on data modes, which mode to choose, and I'm then going to concentrate in a little bit more detail on FT8, because as you probably noticed if you looked around, it sort of dominates data modes at the moment. So why bother with data modes at all? Well, our hobby is supposed to be about self-education, and this is a valid area of radio experimentation, so it's good for self-education. It's particularly good, as David alluded to, for QRP and DX, and when conditions are poor, you will often find there are still data signals, so you can still keep operating. And one of the things you might not think of, but it's a fantastic propagation tool. You've probably all heard of Whisper and have been using Whisper as a propagation tool, and it is really excellent to be able to see almost in real time how you're getting out. But you can also do it with FT8 and get real-time reports just a few minutes after you've transmitted as to where you're being heard and also what your signal strength is in those locations. So it's a really valuable propagation tool, even if you don't want to use data modes for communicating as such. As I've said, there's always activity on data modes, and it's free. One of the great things about amateur radio and data mode software is virtually all the software that you need to do all the data modes is completely free, is pulled together by enthusiasts, and the ones I'll be talking about here today are live and updated regularly. So you get really good quality software designed by very good people, absolutely for free in the true tradition of sharing. So what are data modes? Well, they're a text-based communication system in the main. Most of them use a very narrow bandwidth. But you may ask, why are there so many modes? Well, it's because data modes encourage experimenters. And if you're a coder, as you'll see, it's actually quite easy to develop a new mode. So modes are constantly evolving, and when you look at a program like FLDigi, for example, which you may have looked at, and you'll see there's just loads and loads of modes on there. A lot of those have fallen into disuse, but in their time they were very good. So it looks as though there are so many modes that are being used, but there aren't. There's only a few that are in regular use. So the first thing we need to understand about data modes is serial data, because virtually everything that we're talking about here uses serial data. So we just need to simply understand what serial data is, and it is very easy to comprehend. And the simplest bit of serial data is Morse code. So as you can see in this little animation, when we send Morse code, we actually send a serial data stream. So we send the letters one after the other, and each letter, the elements that make up that letter, we send them one element at a time. And that's all a serial data stream is. It's breaking down your message into one bit at a time and sending one bit at a time. So if we move on to what happens when you're on the computer, and say you were to press the letter A on the computer. Now, computers only work in numbers, as you know, and A in ASCII, which is the standard letter set used for computers, etc., equals 65. But computers don't understand decimal numbers, so that gets converted to a binary number, because computers can only do with ones and O's and ons and offs. So if you want to see what happens when we press a key and want to send it out as serial data, this is basically the process. Binary number, and then there we go, just like the Morse code, 1 bit at a time, we send the serial data out. And one thing to notice here is that we send it backwards, if you like. So that's the least significant bit, the final one there, and we send that one first. And that's the standard way to send information. Now, you don't need to know that detail to operate the data modes, but as they're all based on this type of transmission, it's quite useful to understand some of the basics of where we're coming from. So from that, we've established we need to be able to communicate two states, which is a 1 and a 0. Now, we could do what Morse code does and uses a carrier on and a carrier off. But the problem with that is we want to decode this with a machine. In the old days, it would have been with a teleprinter, and now it will be with a computer and a sound card. And on-off keying is really difficult for a machine to handle, because as the signal gets weaker, it's very difficult for a computer to differentiate between noise and a very low-level tone. So it's not really practical. You would have seen from Morse decoding programs that up until fairly recently, it's been really difficult to get a good software Morse decoding program, and it's for that reason. So the solution that was quickly adopted was to switch between two carriers, so that there's always a signal there. It just switches between two frequencies. And the definition or the name for that is frequency shift keying, fairly logically. And that was used in the early days of radio data communications. And it was used for radio teletype, which was teleprinters sending signals over radio. It was used for weather reports. It was used for communicating out to ships, etc. And it worked very reliably for a long time, and it's still currently in use when you send RTTY signals. So the difference between the carrier frequencies is called the shift. And that's a term you might encounter, particularly if you're doing RTTY stuff. So here's an example to show you what the shift means. So if you think of this bit of serial data, we've got the two states, a 0 and a 1. And if we were to say, represent them with a signal of 14 megs or 14.001, then the shift would be 1 kilohertz. And it's as simple as that. That's all the shift is. It's the difference between the two frequencies that we use for 1 and 0. So when all this started up, of course, in order to do this switching between two carrier frequencies, you needed a specialist frequency shift keying transmitter, which was a problem. Some of the early amateur radio kit did come with FSK fitted in it, but most didn't. But the thing that changed everything was the introduction of SSB transmitters or transceivers. And they became generally available, and nowadays pretty much everyone who's on the air with amateur radio has an SSB transmitter available to them. And using an SSB transmitter, you can simulate frequency shift keying using just audio tones, which is brilliant. So how does it work? So let's illustrate that here. So in the bottom left-hand corner, we've got a signal generator. In the top left-hand corner, we've got an FT897 transceiver set to 14 megs USB. And in the top right, we've got a frequency counter. So if we generate a tone, say a 1 kilohertz sine wave, put it into the microphone socket of the transceiver, what will we see at the output of that transceiver? Well, we'll see 14.001 megahertz. That's assuming that it's set to upper sideband. So let's try another tone. So if we change to 2 kilohertz, what will we get? We get 14.002 megahertz. So if we look at that, what we're getting there, if we increase an audio tone by 1 kilohertz, the carrier shifts up by 1 kilohertz. So what we're effectively doing there is putting a frequency shift in audio produces exactly the same frequency shift at RF. So we can do audio frequency shift keying, and it looks like RF frequency shift keying. So that's a really important concept to understand with how we generate data mode signals and send them out over your SSB transceiver. One important point to note, and people often get confused with this, is that you always have to use USB with data modes. Okay, you have to ignore the convention of 40 meters and below where you swapped a lower sideband. You don't do that with data modes. If you did that, what you would do is your tones would be upside down. So when you put a 1 kilohertz tone in and increase it by 1 kilohertz, the carrier frequency will reduce by 1 kilohertz. So don't use LSB because you will be uncopyable. So always at USB for data modes. Okay, so what about now the other direction, the receive direction? So if we put a 14.001 megs carrier into the transceiver and measure the output, we'll get our 1000 hertz. No big surprise there. And again, if we put 14.002 megs in, we'll get a 2000 hertz tone out. So what you can see there is right the way through the chain, from audio to audio at each end, whatever carrier change we make at the audio on the send end comes out at the other end. Now that might be stating the obvious, but often people tend to think differently with data modes, and you don't have to. It really is as simple as that. SSB transmitters mean we can create almost any data mode by putting tones into the microphone jack or the audio input of the transmitter. And that frees us up enormously, because before we had SSB transceivers, there were a lot of extra things you needed to add in order to do data modes, whereas now there's very little. So again, the warning: must use upper sideband. So what really changed data modes and kicked off all the new data modes on the scene was the introduction of computer sound cards. And any of you who have been about as long as I have will remember the Sound Blaster cards of the 1990s. That's probably the most popular card. It was very well priced at the time, and it almost became the universal standard for sound cards in computers. They all had to be Sound Blaster compatible because that was the standard that everyone was working to. And of course, once you've got a sound card in the computer, that completely opens the door for data modes via computer, and that spawned the development of lots of new data modes, phase shift keying as well as frequency shift keying. So you can do those as well. It's not restricted to frequency shift keying. Anything that you can emulate in audio, you can send through an SSB transmitter and use it. So that really makes the generation and reception of data modes quite straightforward. But there are a few things you need. So the amount of extra equipment you need really depends on what type of rig you've got and how old it is. So there are two categories basically. There's rigs without a USB connection, and there's those with a USB connection. And the USB connection is normally for handling the audio and the computer control of the rig. So let's start for rigs that haven't got a USB connector. So in this case, I'm using the FT897 because that's a good example of a very popular rig. So you need to connect an audio output from the rig through to the computer. Now, while you can use the external speaker jack, it's not recommended, because if you use the external speaker jack, the volume control on the front determines the sound you'll get, and it also suppresses the internal speaker, so you can't hear what's going on. By far the best way is to use the accessory jack at the back of the rig, or sometimes it's a data jack, where you can take off a standard level audio signal to pass through to the computer. And that is not affected by your volume control, so you can choose to listen to the sound or not without affecting the data. Going the other way, you need the audio out of the computer to connect through to the mic input, or preferably the data or accessory input on your rig. Most rigs in the last 20 years or so have got a data input and output connection. Excuse me. The other thing that you might like to add is computer control of your rig, so you can change frequency and transmit and receive, etc. The reason I say that that is useful is because most data mode software have got computer control facilities in them, so you can actually run the rig as well as the data modes from within the data modes program. So if you change band in the data modes program, it will automatically swap the rig frequency, and also for login purposes it will get the settings from the rig and put it in the log automatically, which is very convenient. You can make your own leads to do this. It's not at all difficult. There's nothing complicated in there. Very often people put transformers in the audio leads to try and put a break between the computer, which is potentially RF noisy, and the rig, and also putting a audio transformer in the leads helps stop RF getting back to the computer. But it's also quite handy to put a couple of potentiometers in those audio leads, so you can adjust the receive and transmit levels, because most rigs want different drive levels for different bands for a given power. So that's what you need to set up for a rig without USB. One other option you can have is to buy a ready-made interface. So Signal Link are well known for interfaces, but there's lots of others. And generally what they do is they have a USB connection that gets through to the computer, but on the other side you buy a dedicated set of leads that go from the interface unit to the rig. And then that handles all the links you need between the rig and the PC. And you'll see this one's got level controls on the front, which is quite handy. So that's what that interface provides. Some of them do cat control as well, which can be quite useful. So let's move on to rigs that have got a USB connector, and this is by far the easiest way because that's all you need. Okay, so it's really simple. You just need a USB cable from the rig to the PC. But let me just show you what's going on inside when that happens. So this is an approximation of what most rigs would have inside in order to do that. So the audio in and out from the transceiver would be sent to an internal sound card within the rig, where it will be digitized and sent to a USB hub, which is also inside the rig. Then for computer control, you would have whatever system they use for controlling the rig connected to a serial adapter, which then connects to the USB hub. And then finally is the cable you see between the USB hub and the PC. The great advantage with this is not only is it simple to do, but also all the interfacing of matching of levels, of isolating to stop RF and interference getting back and forth is handled in the rig. So it's by far the simplest way to do it. So what software do you need? So you've got the hardware set up. So what do you need in the way of software? Well, you just need two free programs. One is FLDigi, which is constantly updated. The author is always adding little tweaks, adding extra support for extra transceivers, etc., fixing little bugs that creep in from time to time. It covers a huge range of data modes except for the weak signal ones. And it's available for all the computer platforms that we encounter as amateurs. So Windows, Mac, Linux, and also on the Raspberry Pi. And I sell cards, incidentally, with these two programs pre-installed on them for the Raspberry Pi. And certainly the latest Pi 4 makes a wonderful data modes interface if you want to avoid using your main computer. The second program we need is WSJTX, which you've probably all heard of. This is Joe Taylor's suite of weak signal software. And the whole range of all those software modes are in this one program. And again, it's available for Windows, Mac, Linux, and the Raspberry Pi. So it's a pretty universal program. It's constantly being updated. It's going through an update at the moment to add some brand new modes for LF and MF work. So two excellent programs there. One other thing you need to think about, particularly for the weak signal programs, is most of those rely on synchronization between stations, i.e. they use time slots for transmission and time slots for reception. So it's important to have a reasonably accurate clock. And it needs to be no better than a second accuracy. You don't need fancy NTP Stratum servers around you and everything. You just need better than 1 second accuracy. An internet connection will provide that for you. The only thing you might want to watch is that the Windows default update for the clock is weekly. So once a week, it will go and check how far out the clock is and put it right. So depending on how your clock drifts during that week, you might want to use some software tools to increase the accuracy. And here's a set of programs, popular programs, probably in order of popularity, that you might like to add. Basically, they just check the internet more frequently and keep your clock up to date. So what are the popular modes? Well, in my view, these are the most popular modes: FT8 and FT4, PSK31, JT65 and JT9, Whisper, RTTY, and Packet. I'll just run through those briefly so you can understand a little bit more about them and where they might be appropriate. So FT8 and FT4 have dominated since their introduction in 2017. They are by far the most used HF data modes programs. They use what are called structured messages. So it's a very rigid, fixed messaging system, and you basically only exchange your call sign, your locator, and signal reports. And there's only one small field where you can add a little bit of personalization, but you've only got 13 characters for that. So it's very much fixed messages. The time slots are 15 seconds for FT8, so it's 15 seconds transmit, 15 seconds receive, 15 seconds transmit, and so on. For FT4, which is designed to be a faster system, it's half that, so it's only 7.5 seconds. All signals are contained in a single SSB voice channel. And the other great thing about it is the software will decode all the stations in that channel simultaneously. The bandwidth for each signal is very narrow at 50 hertz, but the sensitivity is excellent, so it works under very poor conditions. So this is what FT8 looks like when it's running. You'll see in the bottom corner there is a bar going along which is clicking away the seconds. At the end of each phase, you'll see the received call signs scroll up on the left. So we're in a transmit mode at the moment, and then here comes the decode. Okay. So it might look complicated initially, but it's actually quite straightforward. Over here on the right, down here, is all the standard messages, because the program generates them for you. To start a call, all you have to do is double click on station calling CQ. The program will automatically populate all the messages with the right information. And as soon as that station responds to your call, it will tick through those and making it very easy. So PSK31, this was before FT8, PSK31 was the mode that everyone used. It was designed specifically as a chat mode, i.e. for free text calling. Much the same as FT8, all the band activity is contained in a single SSB channel, and most decoders will decode all the signals in that band. JT65 and JT9, both predecessors of FT8, use structured messages again, so there's no opportunity to chat, but they're slightly more sensitive than FT8 and particularly good for very weak signal paths. Now, Whisper, you've probably all heard about Weak Signal Propagation Reporter, and it's an excellent tool for checking your signal. Also for checking propagation paths to see what's opening up. Uses a 6 Hz bandwidth and a 2-minute transmit receive period. It runs well on old computers, and the Raspberry Pi can be set up as a self-contained beacon, so it will transmit signals all on its own. You can upload reports to WhisperNet and view the results on a map or database. So this is an example. I put out a couple of calls on Tuesday morning last week, and this was the result I got back within a few minutes, so I can see where I'm getting out to. You can also see it on a database format like this. So you've got all your signal reports coming back, really detailed stuff, an excellent tool. So RTTY. RTTY is a simple free text mode. It's been around for years, but it's mainly used for contests these days. There are a number of dedicated RTTY contests, and it's quite a fast mode to use for contests. Most operators will use what are called macros, and that's where you store common messages to save typing, so you can just hit a button and send popular messages. APRS and packet radio, similar to Internet Protocol, but it's really a VHF, UHF only mode. And in the UK, it's primarily used for automatic packet reporting systems. So that's a quick run through the modes. So let's just, as we're coming towards the end now, let's just look at operating FT8. Now what I've got here is the main screen, and I'll just run through, which I'll just find in the right place in the slides here so I don't miss anything. Yep. Okay, so let's start this running. So
I must say, just Mike, just to give you a tiny little break for a sip of something or something like that, just to remind everybody at home that, as you could probably realise, this is live, Mike's live, and you can ask him questions about anything he's told us about so far. So just enter your questions or comments on the YouTube chat right now, and we'll be able to ask them to him directly to Mike at the end. And back to you, Mike.
Thank you. Okay, so let's get on to some more practical things about actually getting set up. So let's just explain how the calling process goes. So let's just start this off. So we've got here EA3 IGB is putting out a CQ call, and that's what he'd send. Now, if I want to respond to him, all I do is double click on his call sign in the program, and my system will automatically go back with this. So the normal EA3 IGB G4WNC, and it will send my locator, the first 4 digits of my locator. If he receives me, he will send back my signal report, -19. This is in dBs below the noise in a 2.5 kilohertz channel. I will then reply with an R to indicate that I've received my signal report, and I'll send him his signal report. And he will then reply RR, which confirms that he's received both directions of the report, and he's saying cheerio. And then I finally respond with 7.3. Now that's the pattern of all QSOs on FT8, and these messages are generated automatically. So all I have to do is double click on the station I want to call, and it will generate these messages and actually track the call through automatically. So a couple of things to be wary of. It's very important to set your transmit drive levels correctly. So start with a dummy load connected. Set your rig for low power. 5 watts is usually enough for FT8. And use the tune button to transmit. And then you adjust the drive with the transmit control on WSJTX. So here's a quick look at that. So here's the tune button over here. And this is the transmit drive here. Now, the state you want to get to is so that as you move this up and down, you can actually see your output power changing. Okay, because that means you're not overdriving. If you move this up or down and your output power doesn't change, that indicates that something is limiting and you need to investigate. So it's a good test of whether you've got the audio under control. Now, one of the things about FT8 is it's normal to use split frequency operation. And this is not a complicated process with FT8 because it's all done at audio. It increases your chances of success. And you use the wide graph display in WSJTX to find a slot. Once you've found a slot to transmit on, FT8 software will automatically lock on your receive frequency to anyone who's calling you. So here's how you use the wide graph. So this is what it looks like. It's a spectrum display and a waterfall. The waterfall being the most useful one for finding slots. So if you shift click here, those little red brackets will appear, and that indicates where your transmit frequency is. So what you're looking for is a slot which hasn't had much activity in it. And you set that. Your receive frequency at the moment is over here, indicated by the green bracket, but that's set by the software, so you don't need to worry about that. To get the best display, you can use these controls down here to adjust the contrast, etc., of the waterfall control. And if you want to adjust the spectrum, you do it with these controls. So let's look at an example QSO, which will show you what's going on. So if I start this, this is a video of a QSO I had this week. So I'm going to start by hitting the CQ message at the bottom. Okay, and that will cause that CQ message to be the first thing I send. And then I need to go to enable the transmitter, which you'll see me do now. And then you'll see my call going out at the top. So that's my CQ call that's being broadcast. It's going to do a little time hop now and to another CQ call. And what we should see any minute is some people responding. There we go. So I've got 3 people responding to my call. So PA0 LDE, DG2EM, and DL6MHC have all responded. Now, it can be quite difficult to decide which one to answer if you're new. So if you come down here to the call first button and activate that, the program will automatically pick the first person to respond and start responding to them. So if you see now, there we go. It's automatically picked up PA0 LDE and is making that transmission. And if you see down here in the messages, it's put those messages in, so they're already in place. So we'll carry on and let it roll. So that's just going through the this is real time now, going through the transmit cycle. Here's the receive cycle coming. And at the end of this, we should see some results from PA0 LDE. So there we go. So in there, you can see that's my signal report. He's received me with the R and -13. But down here, you note that DL6MHC is still calling me. We don't have to worry about that. You'll see here, this indicator of what message we're on is automatically switched down to there, because I've now received everything I need from PA0 LDE, and I'm going to send my 7.3 message back. Remember, it's doing this all automatically. All I had to do was put a CQ call out. So here we go. That's my final to PA0 LDE going out. Now, one thing to note here is that to stop a fully automated series of QSOs, the program automatically disables the transmitter after you've sent your final message. If it didn't do that, you could actually go down the pub at this point and it would sit here working everyone that it could find. And so we can't have that, so it's disabled automatically. So it's just finishing that off. And I'm now going to enable TX so I can pick up the next caller. So at the end of this cycle, there we go. DL6 MHC is calling me. So it's now automatically populated this list with that call sign and is going back to give the call. So as you can see, it might look complicated at first, but this is all automatic. The only thing I did in this process was to call CQ. And I can hit the CQ message and go on again, etc. So that's an example QSO, just to try and illustrate how easy it can be to make a call. So a few operating tips as we're coming just to the end now. There's a really good online guide to WSJTX. So I suggest you refer to that. It's got getting started sections and everything. It's really good. Also, Gary Hinson, ZL2IFB, has an extensive guide to FT8, which has pulled together his own experience of using FT8 for a long time, together with lots of other people's. And it's a really useful guide if you want to get a bit more out of FT8. So remember, set your TX, your transmit frequency, on a free slot using the wide graph, because that'll improve your chances of success. And do be careful of the audio levels, because if you overdrive the audio, the distorted audio signal that results will go into your SSB transceiver, and all those distortion products will be broadcast, and it comes out as a real mess. So it's just one thing you need to be careful of in particular. And as far as managing your transmit power, if you get a positive signal report as opposed to a negative one, you should consider reducing your power, because this works best with small signals. Someone with a massive signal in the band makes a mess of it for everyone else. So really manage your transmit powers using that slider on the right of the program to make sure you only get 0 or negative signal reports. Okay, so my summary now. So why data modes? Well, they're cheap and easy to get started. Most of you can do it probably for free, particularly if you've got a USB connected rig. It enhances your communications skills. It's more things you know how to use. When you're stuck for activity because the bands are rubbish, you can bet your boots you can still get out somewhere with data modes. Now, I've included a web link here. I've sent this on paper as well. I suspect they'll put this on the site somewhere.
Absolutely, Mike. What we'll do is we'll get them added on once the recording of this program goes out. Then we'll make sure we add that to the YouTube stream. Lovely.
And finally, if you want to know more, I've got to do a sales pitch. I supply SD cards for the Raspberry Pi. They're all pre-installed, ready to go with instructions. I do a data modes one, which is very popular, which has got all these data modes on them ready to go. And as I said, one of those with a Pi 4 makes a great little data terminal if you don't want to mess with your main computer. I've also got lots of other tips on my site. And if you want to show me full screen, I've got just plug for the Raspberry Pi explained book, which the RSGB sell, because that's my book and it's going quite well. And I think it's very useful. I use it all the time. Anyway, that's about it from me, David. I think I'm on time.
You are absolutely on time. Look at that, with 50 seconds to spare. Real pro. Thank you very much, Mike. And I can endorse, by the way, what Mike said. I know he couldn't say this, but his cards, and they're only, what are they, £8, £10, something like that, Mike?
£9.50.
£9.50, including postage.
Free postage in the UK.
Including free UK postage. They really do help you if you're just starting with a Raspberry Pi. It's a wonderful little kit, that is, isn't it? But you get it, and it's quite daunting because you don't know what to do with it when you get it, unlike a normal computer. So I can recommend Mike's cards for that as well. Anyway, Mike, thank you ever so much for a fantastic talk on data modes and lovely animations and things, which made it really easy for people to follow, which is the whole point of this stream. A few comments for you and questions. Robin, M7EDM, a new amateur, I think, he says, I need this. You said this right at the beginning of your talk. I managed my first FT8 QSOs just yesterday. So that's brilliant.
Oh, good.
Lots of other people are saying hello and thank you very much. And Dorothy and was obviously someone who's well known. Dorothy Stanley, give her a name check as well. And we've got a few other specific questions. Someone said, Stelios said that Sound Blaster AW32 was the top one. I guess that was the top sound card of its
Hang
time.
on a minute.
Have you got us?
I've just got to do...
Okay, well, while Mike's just adjusting something at home there, just a reminder that this is live, as you can see, and if you want to ask any questions, do it right now. We've only got less than 10 minutes to ask Mike some questions, so do it on the YouTube chat. If you can add your call sign as well, that would be great. Let's go back to Mike now. Can you hear us, Mike? Mike?
Yes, I'm back now, I think.
Right, we can hear you, and you can hear us?
Yes, I can.
Excellent, okay. Yeah, that was just a question. Someone had mentioned, Stelios has said that the Sound Blaster AW32 was the top one of its time.
Oh, yeah, it was. Brilliant.
Yeah. Okay. Someone has asked him, Mark MD0OMY, says, re the signal link. I've never understood what the DLY knob is for. Could Mike explain that, please?
Oh, right. It's only on the PTT line.
So what does it do?
Don't really need it for this.
You don't really need it. Okay. I think we might have a few internet challenges with Mike, but we'll struggle on. Johnny 2E0HSY has said, I'd like to know about the Raspberry Pi Whisper standalone setup as well.
Yep. It's fully described in the book.
Okay. Just to give you a quick overview of...
if you Google it, you'll find there's lots of references to it. It's what it does. It uses a pulse width modulation line that's available on the Pi to generate the RF signal. Okay. Now it generates a square wave, which is not very friendly, but all you need to do is add a low pass filter, and it does a decent job. And it will sit there quite comfortably, acting as a whisper beacon. And you can do it with the oldest Pi there is. So if you've got one you've never used before because it's been sat in the drawer, you can resurrect it for doing this.
I think there's lots of those, don't you, Mike? I'm one of them. Got it and thought this would be good.
No,
plugged it in and thought, now what do I do? You know, I'm not a software person like a lot of people maybe aren't. And really, so as I said, your cards really do help with that. And that book, available from the RSGB shop as well. And about £10, something like that, Mike, I think? Roundabout?
I think it depends on whether you remember or not. I think it's about £15.
15, okay.
To 16 for non-members. I can't remember.
Relatively modest for a book nowadays, anyway, for a printed book, and it really is very good. We've got a question.
I wrote it as a reference. Yeah.
Yes, Mike G4GUG. Don't forget JS8 call as a conversational mode.
Yes, it does. Yeah, I didn't mention that because it was a beginner stream as much as anything. But yeah, JS8 call is a variant of FT8, which is one of the benefits of open source software. People can produce variants. And what he's done, he's adjusted it so that instead of having structured messages, you can use it for free text. But it is quite slow because it goes at something like 8 words a minute, 5 or 8 words a minute. So it's relatively slow, but you can use it to chat at least. Okay,
yeah, so that's quite useful. I mean, this WSJT software, which has been the heart of your talk, really, that is completely free, isn't it?
Oh yeah, it's authored by Joe Taylor leads it, but Bill Somerville and various other people are in there as major contributors, and it's a fantastic piece of software. And when you look at the people that are involved in designing it, I mean, Joe Taylor's a Nobel Prize winner. So you've got some really smart people putting that software together.
And we should just tell people at home now that the JT is Joe Taylor, isn't it? That's what it stands for, yeah.
Yeah, and the stuff they produce is groundbreaking stuff, really. It's really good.
David M0VTG says, can you say something about drivers for rigs and PCs for the benefit of newcomers, please?
I wonder what he means by drivers for rigs and PCs.
Well, I guess maybe drivers for, maybe if you've got like a rig, like a 7300, which has got, I think, a USB socket on it, do you need to install drivers and things inside your computer?
No, it uses standard Windows drivers because all it appears as is a standard sound card and a standard serial port adapter.
So I guess
So
most of these PCs now, you have things like HID drivers and things all built in.
yeah, it is. Yeah, so it'll just work. You need software that will talk to it, so you need a data modes program that will talk to that radio because it's still got to send the right commands to it, but you don't need drivers as such.
Okay. I've got no name, I'm afraid, for this. It's Mabby66 is his YouTube name. Question: I've heard that FT8 can be damaging or stressful to the transmission circuits in a transceiver. Is there any truth in this?
Well, only in that it's a constant power system. So if most SSB transceivers are not rated to run at their full power continuously. So if you've got a 100-watt SSB transceiver, the chances are that it's only rated to work at around 30 watts continuous. And that's the only way. If you try and drive it at 100 watts continuous with a data mode signal, then you'll probably find it shuts down. But a modern rig shouldn't be damaged by that if you've got a good antenna match. It will cause it to overheat, and then there's usually a protection circuit that will shut it down. So yeah, it's a constant carrier mode effectively. It's like a key down mode, if you like. And so many transceivers are limited in what that power is.
So just make sure everything's matched to make the most of that power. Make sure it goes up the aerial and nowhere else.
Yeah.
Okay. I've got a question that's shared between two people, both Mabby66 who just asked and also Super8. Again, I'm sorry I don't have your name or call signs. Would like to be able to use FT8 by controlling my rig with an Android phone for SOTA, for Summits on the Air. Are there any apps for this? And the same question actually for iOS as well from Super8. So any Android or iOS apps for running FT8 as far as you know?
I don't know. No, I somehow doubt it because the main FT8 software. No, I don't know. I'd have to have a look at that. I haven't come across it, but that might be because I haven't looked.
All right. Okay, that's fine. Essex Ham have come back and said that it's worth mentioning that FT8 is great for newcomers with power limits. Worth a mention as well for SSTV, downloading images from the ISS with a cheap handheld and a smartphone to get used to the concept.
Yeah, I agree. Yeah, I mean, it was very difficult with this to decide what modes to cover, and yeah, SSTV is a really interesting mode. The only reason I didn't put it in is because it's very different to this. So I was trying to follow a theme with this one, as that's why I started off with serial data and that whole bit. But yeah, SSTV is well worth investigating, and the low power side of things that you mentioned in the previous question, I would emphasise that really you shouldn't be using much power when you're using the WSJTX modes. You really don't need it. There are a lot of people using way too much power on the bands. I usually start at 5 watts and turn down.
Turn down? Well, okay.
Yeah.
That's good. One of our guests, presenters this morning was Kevin Richardson, G0PK, and he said, are data modes killing the art of conversation?
No. And
I know, maybe a bit tongue-in-cheek, but, you know, it's a thought.
No, I don't think they are. I mean, admittedly, FT8, you cannot converse. There is no way at all you can converse with someone on FT8. It's literally making a contact, the theoretical minimum of a contact. And you might say, well, that's what's killing conversation. But if you go back to the previous mode, I like to say to PSK31, that was a free text mode where you can type anything you like, but everyone used macros. And so you ended up with fixed messages and no one wanted to talk, or a lot of people didn't want to talk. And if you go back again to RTTY, everyone used macros. And so again, it was stored messages that people were using.
That's what started it all, really, isn't it?
Yeah, that's right. So I think it's very easy to say now, look at FT8 and say, well, that's just an impersonal automated mode. Why are you bothering with that? But we've actually been working up to that over a period of time. And there are different things about this type of operating. It's been able to use very low powers. It's been able to work over really marginal links. And people get technical enjoyment from using the computer side, linking it with login programs and alerting programs, and it's a whole different world associated with data modes.
And also we've got to
which is
remember
not-
we've been at the bottom of a sun cycle already, so we've had the worst conditions. So that's when we've been probably grateful to have something like that where we can at least make some kind of contact.
Yeah, and also what you shouldn't forget is that it's absolutely brilliant for checking propagation.
Yeah.
So with Whisper and also PSK Reporter, if you use FT8 and do the uploads to PSK Reporter, you can see all the stations that have received you on a map. You can see when they received you, and you can see the signal level that they received. And you get that within a few minutes. So if you're playing with antennas or your station or whatever, you can just put out a couple of CQ calls, go on PSK Reporter and see how you're getting on.
Lovely.
So it's a really powerful tool.
Yeah. Stephen G7VFY says, what's the most sophisticated Morse decode program and what does it run on?
Oh, goodness me, I don't do it. So
Caught you a bit on the hop there, I'm afraid.
Yeah, I'm having a mental blank at the moment.
I tell you what, don't worry too much, because I know we've got a friend of mine coming on later on, Jim Bacon. He's really into his CW. So if you don't know the answer off the top of your head, I will ask him to let us know on the program he's got for us at 4 o'clock. But don't worry about that.
Yeah, I rather think Morse code. I don't really include Morse code as a data mode because I think it's a bit of an art form.
I think you'd agree with that.
Yeah, the send and receive of Morse code should be a human thing.
And by the way, there is a link to your latest book on the YouTube chat. Mark Algar has put that up for us. We can go straight to the RSGB shop. I think he's got a slightly vested interest there. He deals with all that side of things. G1FBH, we're running right on to the end of our time now. Vince, you talk about Sound Blaster cards, but most computers I have here have built-in Realtek sound cards. Is there a problem using them?
No. I only mentioned Sound Blaster cards because they were the originals. They're what started it. There's hardly any Sound Blasters about now. I think they've been bought up and absorbed. Almost everyone as standard has a Realtek chipset in there. But all the modern audio chipsets are fine. There's no issue with them at all.
I've had an answer back on the app who says that David G4NRT says the best CW decode program is the Mark I Human Ear.
That's right. Right. I agree. Yeah. Definitely.
Well, lots of people have and also QRP Labs transceivers include a very good CW decoder there as well. A few other comments there, but we have run out of time, Mike. Thank you ever so much for this afternoon's talk. Love the animations. Aimed perfectly, I think, for all of us who are just starting in all this sort of thing, and unmystified some of those things about how you connect everything up and how you get the best from some of these new modes. So thank you ever so much this afternoon. Let's thank once again to Mike Richards, G4WNC. Mike, thank you.
Yeah, one final point. I know you're going to go. If you want any of those questions answered offline, I'm quite happy to do them via email.
All right, that's fine. So Mike's email address. Do you want to just quickly give your email address?
Yeah, Mike at g4wnc.com.
Mike at g4wnc.com. Lovely. Thank you ever so much.
No problem.
Thank you very much.
Have a good afternoon.
Yeah. Thank you.